let's do some dimensional analysis or some unit conversions, right? Let's do some of that stuff, right? So here's a person. He weighs 178 pounds. I wonder what his mass is in kilograms. Uh, I don't know if you've ever done dimensional analysis before, but this is the easiest way that I have found, and most people teach it this way, to do conversions of any units, okay? So let's start out by saying we need, with the information we have, which is 178 pounds, right? You draw a line like this, and then you draw a line down like that, right? And for every pound, oh, sorry, and you're going to kilograms, right? You're going to kilograms. For every 1 kilogram you have, right here, apparently there are 2.20 pounds. Okay, cool. All right, very cool. This is the easy part, right? You cancel out pounds and pounds because one is above the line, the division line, and one is below, right? So you're just left with kilograms left, which is what you were looking for to begin with, right? You're just left with kilograms, right? And it's what you have when you began with. I mean, yeah, sorry, it's what you have, what you need, right? You need to go to, so you have kilograms left, and now all you have to do is multiply across the line like this, right? So that would be 178 times one, all right, times one, and then divide below the line, right? So that would be 178 times 1, which equals 178, and then you divide by 2.2, and that gives you your answer, right? And just to save time, I'll show you the answer is then 80.9 kg, right? Let's just not save time. Let's actually show you how to do this. Look at that. Looks like we're doing a lot of math, like a lot of hard work. I love it when I see numbers on my calculator. So 178, right, times 1 from the 1 kilogram. The kg stays there, but you can't put a kg into the calculator. You just got to remember that that's still left because the only thing you canceled out was the pounds. One was above the line and one was below the line, right? Cool, right? And then we're doing order of operations here, so the calculator will know. You did 178. Oh, lost connection. Oh, there it goes. Uh, 178 times 1, and then divide by, right, the 2.2 pounds. Or, sorry, 2.2, yes, the 2.2 pounds. And I get 80.09, right? 80.09 kilograms. But you're asking yourself, wait a second, what are all the other numbers? Remember, you got to do significant figures here, right? And the lowest number of significant figures available here is that one number that you had. That one piece of information that was given to you was 178. How many significant figures are there? That's three significant figures. So that means that you have to put in your answer as three significant figures, right? Oh, you can't even see that because the calculator is blocking it. I wrote 80.9 kg. Can you see that now? Most of it, anyway. Right? So when you're looking at the calculator, notice that behind the decimal point we have our 9, but then the number after that in the hundreds place is a 0, and the one after that is a 9 again. So 9 actually makes it where you would round up, right? That's 0 to 1. But then that 1 is below 4, so you round down, right? You don't have to do anything there, and so that's why it's 80.9. Cool. All right, let's keep going, right? Let's try another one. I'll try not to do my math into the calculator screen. We have a rattlesnake. Ooh, rattlesnakes. There's a lot of those in Texas. Are there? I don't remember. Anyway, you have a rattlesnake, and it is 2.44 meters long. Right? 2.44 meters long. Right? I don't know why I wrote the word long there. We don't need that word. How many centimeters long is that same rattlesnake? You do the same thing again. You draw that line. You make this little cross here, which means multiplication. The line that goes horizontally is, remember, the lines that go vertically are always multiplication lines in dimensional analysis, and the lines that go horizontally are division lines, right? So it's a 2.44 meter uh, long rattlesnake. How long is it in centimeters? Well, you look at your unit conversions, and you see what the equivalent is, right? Which this is actually really easy because it's the metric system. turns out that there's 100 centimeters, right, for every 1 meter. Same thing again, the two m's above and below the line get canceled. All you're left with now is to do 2.44 times 100 divided by 1. And that's really easy, right? That just gives you 244 centimeters, and you've converted that. Okay? Oh, here's something a little bit different. Time. How many minutes are in 1.6 days, right? So let's just start with what we have again. We have 1.6 days. Draw the line across, right? The division line. And then draw the multiplication line, right? For every 1 day, just remember that when you're trying to get rid of a unit and move to something else, you're trying to cancel that unit. So you want to put that unit that's been canceled below the line, right? Below the division line. So for every 1 day, you have 24 hours, right? And then for every 24 hours, or sorry, not for everyone, for every 1 hour, you could put 24 hours again, but that would just be unnecessary math. But then for every 1 hour, you have 60 minutes. That's where you stop because you're looking for minutes, right? You're looking for minutes. So, since you're looking for minutes, you don't need hours either. That's why you put hours above and below the line, right? So let's do this here. You have days, which cancels out down there and up here, or up there and down here. And then you have hours that cancels out up here and down here because they're both above and below the line. What are you left with? You're left with your unit that you're going to, which is minutes, and the numbers. Oh, this is really easy because everything at the below the line is 1, right? So you don't even have to worry about dividing because anything divided by 1 is itself. So you do 1.6 times 24 times 60, and your unit is minutes, right? This then equals what? Just so you know, I'm going to go ahead and tell you the answer without using the calculator because it's a very simple multiplication on the calculator. You get the answer of 2,304, right? But remember your significant figures, right? Remember your significant figures. What's the lowest number of significant figures you have? It's actually 2, right? 2 significant figures is lowest. So how do you change that to have 2 significant figures? Right now it's got 4. Well, with 2 significant figures, I almost put SF again, or F again. To SF. There, for 2 significant figures, right? This would actually be 2,300 minutes. Right? That would be 23. Because remember, any numbers that are used as placeholders, like these zeros, are not significant. That's why you could say 2,300 minutes. Okay? Remember your significance. Oh, this is a two-parter right here, sort of, maybe. It's asking you, it's saying that you have this rate, right? Where you're traveling 65 meters per minute on a treadmill. Seems like a long distance. Man, that's like cross country. Maybe it's not. It just seems like a big number. Anyway, 65 meters per minute. So how many minutes will it take for this person, or you, right, to walk a distance of 7.5 kilometers? Well, the target number here is actually the 7.5 kilometers, right? Because you're wanting to, oh, I'm sorry. My face is blocking it again. It says walks a distance, right? The D right here is distance, and it says 7.5 kilometers. Sorry about that, my face is blocking it. So the target here is the 7.5 kilometers, right? Because you always want to start off the target. This is just information helping you get to the target, right? Just remember, when you're doing a chemistry problem, you've got to identify the target. Okay? You've got to identify the target. So let's start it out by putting 7.5 kilometers at the top. Draw our division line and our multiplication line, right? And I said that wrong, actually. This is not our target. This is our information that we need, right? And we're always going to our target. Sorry, yeah. So this is the one piece of information that you need, right, to get to your target. So that's always the first thing that goes in the dimension analysis box. Sorry about that. And then you want to get to minutes, because minutes is your target. There's just so many lines around here. I've drawn so many lines on this page, I can't even see what is going on here. So minutes is right here. right? That's our target. So what do? How do we get from 7.5 kilometers to minutes? I mean, one is a distance and one is a time. That's crazy. Well, we were given this rate that has both in it, and that's what we'll use, okay? So let's start out by saying then, for every 1 kilometer, again, we have 1,000 meters. And then for every minute, we have 65 meters. Remember that you want to end up in minutes because that's your target, so that's always going to be at the top, right? And then you know that this person in 1 minute, because it's right there, traveled 65 meters. This is an equivalence, right? And that's why you can just put one at the top and one at the bottom, right? Because in 1 minute, right, just use English, in 1 minute they traveled 65 meters. Or you could say it the other way around, which is 65 meters per minute. It means the same thing. But we want to put the minute at the top because that's what your target is. Then you'll calculate out the math, right? What do? You multiply everything at the top, and you multiply everything at the bottom, and then you divide it by each other, right? So let's do this on the calculator since I have it already up. Might as well use it since it's blocking all my writing anyway. Clear 7.5 times 1,000 times 1 minute. So you should be getting 7,500 at the top. I think that's what it says. Yes, 7,500. It's hard for me to see when it's on the screen. And then we're going to divide that by 65 because that's at the bottom. And it's just 1 kilometer, so you don't have to do anything there because 1 times any number is itself again. And you get the answer on the calculator as 115.3, oops, not 8, 83, there's 835, and a whole bunch of other numbers. That's not 5, I'm sorry. 4, 6, and some other stuff. But none of those matter. None of those even matter, right? None of those numbers even matter because we're trying to find our. We always have to take into consideration our significant figures. What's our lowest number of significant figures here? Well, it's going to be this guy right here. The 7.5 kilometers is 2 significant figures. So how do we make that number with 2 significant figures? Remember, right? This is a big thing here. Zeros that are used as placeholders are not significant, right? And you got to turn 115 minutes, right, into something with 2 significant figures, right? Well, how do we do that? Well, it's easy. You round it up to 120 minutes. Because now, when you round it up to 120 minutes, you only have 2 significant figures in the 1 and the 2, right? So that's how you do that.